Okay. So what we have here, 4.5.84. If we draw this, let's go ahead and do these by 3. So 3, 6, 9, 12, 15, 18, 21, 24. All right, now let's also do the Y scale since we're bouncing between like 28 or 23 and what is it? 23 and 53. So let's do it by 10. So 10, 20, 30, 40, 50. All right. 60. So if we're looking at this, that told us at noon. So technically, we're going to have these points on there. So it told us at noon, it was 20. I already forgot. Was it 28 or 23? It was 23 inches away. At 3 p.m., it was 15. So that's, everyone agree with me that 3 p.m. is 1,500 hours, right, military time. So 15:38 is on my graph. 6 o'clock is 1,800 hours. 53 is on my graph. 21:38, so that's again 9 p.m. And then midnight is going to be 20. Well, we're going to go with 24, even though military time. We're back. It's 0 hours. All right, so we got those points on my graph. Now, everyone agrees, it told me all these things in PM, but would it really matter if they were AM? Is there any difference on the clock? No, the clock is still going to look exactly the same. So these kind of repeat themselves. So I could, everything I have here, I could just subtract 12 from it and it still work. So I'd have 0.23, I'd have 3.38, so right about here, 6.53, 9.38, 12.23, and then it just keeps on, it repeats itself again. Let's make this one a little bit higher. All right, so if I'm drawing a graph, it's going to look like that. So that's what 84 actually asks us to do. Questions on that? Because it doesn't, I mean, if you think about a clock, the hour hand at each of those spots, it's just like the unit circle, except that we're going around, we're going clockwise, and we're starting at, you know, the 90-degree angle instead of at 0. And so it makes sense that these, like 12 o'clock, 3 o'clock, 6 o'clock, and 9 o'clock would all be key points, right? The 12 and the 6 would be, you know, valley and peak respectively, and then the 3s and the 9s would be our midline. Okay, there it is. All right, so if we're looking at, let's find the equation for this graph, okay? And we're going to come back and there is no, I don't think there's a 4-8 in the book, but I kind of made my own little 4-8 that I want to, where we look at this a little bit more in depth as well. But if we look at this, our amplitude. Anyone, what's our amplitude on this?
30.
15.
38.
No, wait, 15.
30.
Oh,
30.
yeah, 15.
It is 15.
Yeah.
All right? Because, well, one thing you could just, in the problem, the hour hand is of length 15 inches, so that's why it's 15. But what we're really looking at here is basically from the midline, right? We don't have to do this, but we can. That dotted line is our midline. From there, we go up and down 15, right? How can we figure that out in general? Well, we could do max minus min over 2. Does that make sense? Max minus min, that's basically telling me this distance. And so from peak to valley, if I know that distance cut in half, I get my amplitude. That formula makes sense? I'd rather it makes sense than you like memorize. Right, now, another thing we can look at, our vertical shift. Well, where is our midline at? 38. So our vertical shift is going to be up 38. How can we do that in general? Well, do you agree with me that 38 is the average of the peaks and the valleys? How do I find the average of two numbers?
Min plus max divided by 2.
Yeah, add them up, divide by 2. So max plus min over 2. And finally, period. What's our period on this graph? 12, right? It repeats every 12. So I have period is equal to 2 pi over b, and that's equal to 12. So I solve that for b, and I, little swaparoo, multiply by b, divide by 12. I get b equals pi over 6. So, what do you think? What function is going to be the easiest to model this with? Sine or cosine? Cosine, and in particular,
Negative cosine.
negative cosine, right? We start at a valley, so if we model using a negative cosine, we have no phase shift at all. So I could end up with y equals amplitude was 15, so negative 15 because we said negative cosine. Negative 15 cosine of pi over 6x plus 38. And that would be that curve we just drew. And the nice thing about this now, you could say, well, how far, again, maybe not the most useful information, but how far is the distance from the hour hand to whatever it was talking about, at 5 o'clock? Now you plug in x equals 5, and you'd be able to figure out what that distance is, approximately. And actually, in this case, it would be pretty much exact. Any questions on that? One more question then. Take 30 seconds, come up with an equation that uses sign, positive sign. We've done all the heavy lifting. You just got one little thing to do. Anyone think they have the answer? Jack?
Maybe. 15 sine of pi over 6x plus 3, and then plus 38.
You are correct depending on how you wrote it. All right?
Okay.
It's going to be x plus 3 in parentheses if we wanted to make it work.
Okay.
Because remember that phase shift is c over b if we don't have it in this extra factored form. So that's why I greatly prefer this way.
Oh, yeah.
And if I have it written this way, this is shifting it to the left 3. So sine is middle going upwards, right? So our middle going upwards has that 3. We'd have to shift it to the left 3. And I can do that by adding 3. Yes?
Could it not be minus 3, so shift it to the right?
No, it could not be minus 3. It could be minus 9. Right? So I could look at it and say, again, sine.
Why would it be plus 3?
Oh, I'm sorry. I'm working the wrong way. It actually ends up, we do have to, sorry. Sine is here, and we're trying to get it here, not the other way around, right? So we're not trying to, sorry, I said it wrong. Sine starts here, and we're trying to move, we have to move it, so it does have to be minus 3. I'm sorry, my mistake. Or plus 9.
Oh.
Right? I think I made the same mistake you did. I was making this, I don't know, match up with sine, not making sine match up with this. Yes?
Pretty much just shifting it to make it start in the middle and origin.
Yes. Yeah. So thanks for pointing that out.
Why doesn't the plus 3 work?
Oh, because plus 3 shifts this left. Well, so what we're thinking of is if I look at sine, here's here's the unshifted sign, right? So that's not. So we're trying to make the dotted line to the blue, and I inadvertently was trying in my mind trying to make the blue match the green dotted line. But so I need to shift it to the right 3 to make that happen. The other option is I could shift it all the way to the left 9. Then think about it this way: this point would become over here if I shift it to the left 9. So I could have plus 9 or minus 3. Yes.
Could it be like minus? Could there be other options besides?
There are infinitely many, right? I can just keep on adding 12 to it, right? Because the period is 12. So plus 21, plus 33, plus 45, all those would work. Yes?
What would it work if you did like negative 15 sign and then the x plus 30 in parentheses?
Yes. So I said, what if I had a minus sign here and had that be a plus? That would work because negative sign starts going downwards, and then in order to make it work, so it would be going downwards. Remember, that would be, if we continue this over here, right, we would have to shift our graph. If it's sign going downwards, we have to shift it left 3 to make it work. So yes. And we could have also had positive cosine x plus 6 or x minus 6, or like all those things. There are, like I said, infinitely many solutions we could have. Again, this is probably what I would do, right? That's the easiest, no phase shift at all. But there you have it. All right, so any other questions from the homework? Okay, so 4-6. 4-6 is all about graphing. Oh, there. So 4-6 is all about graphing tangent of x, cotangent of x, cosecant x, and secant of x. All right? Now, tangent and cotangent are just slightly different as far as the methodology we're going to use. It's going to look very different, but the methodology is going to be just slightly different. And cosecant and secant are actually very easy if we know how to do sine and cosine. All right? So it's just one step beyond sine and cosine for cosecant and secant. So that should go pretty quick. All right, so let's talk about tangent of y equals tangent of x. So one of the things I like to think about is where does this graph come from? Remember, tangent is the y value over the x value on the unit circle, right? So look right here. This is 1, 0. This right here is 0, 1. So tan of 0 is 0 over 1, so tan of 0 is 0, right? Now what happens as we get close to pi over 2?
Undefined.
Yeah, at pi over 2 it's undefined because it's 1 over 0, right? But what if I did like pi over 2 minus 0.000000001, right? What I would end up with is the numerator would be something really close to 1, 0.9999999, etc., divided by something that's really close to 0, 0.0000001, right? What happens if I take something basically 1 divided by something that's really close to 0? It gets really big, right? It blows up. Does that make sense? So as we're going here, the denominator is getting close to 0, so it blows up. On this side, x is positive, so it blows up to positive infinity. When we're past pi over 2, it's negative, so it blows up to negative infinity. Does that kind of make sense as far as how this graph ties in with our unit circle? It's thinking of it as the y over the x value on the unit circle, and then 1 over 0, it blows up. That's why we have an asymptote. All right, so we have asymptotes at pi over 2, and then the period of tangent is pi, so we have it at 3 pi over 2, 5 pi over 2, negative pi over 2, negative 3 pi over 2, etc. What we're going to end up doing on this one is basically we're going to find our asymptotes. We're going to cut that in half, and that's going to be where we cross our x-axis. Then we're going to cut those in half, and we're going to find out what these points are. And then we're done. Now, you can use all the techniques that we learned before in 4.5. So you can use those techniques on tangent and cotangent just the same, except our period, instead of being 2 pi over b, what do you think our period would be? Pi over b, right? The formula, basically, you can think of the formula as our default period over b. So for tan and cotangent, it would be pi over b. For sine, cosine, cosecant, secant, that would be 2 pi over b. Yes?
Are tangent and cotangent the only ones
Yes, the other 4 are all 2 pi. All right, but we're gonna kind of take a different tack just because it seems to work better for tangent. We're gonna look at where the asymptotes occur, and we're gonna do that using this little piece of information right here. We're gonna figure out basically this right here is called the argument of tangent, like what we plug in, we call that the argument. And so the argument of tan, we're going to set that argument equal to negative pi over 2 and pi over 2. Because if you look at our parent function, tan of x, our first asymptote happens at pi over 2, and our first negative asymptote happens at negative pi over 2. So we're basically saying, but we're setting the argument of tangent equal to those 2 values to figure out what the new values would have to be in order to make it happen where it blows up. So let's go ahead and do an example. All right, so 3 tan of 2x. So if I'm looking at this, to find my asymptotes, I'm going to take the argument. So the argument, again, is that guy right there, the argument of tan, the stuff inside the parentheses there. So tan of 2x. So we're going to set 2x. We're going to say that equals negative pi over 2. We're going to say 2x equals pi over 2. So I get x equals negative pi over 4. X equals positive pi over 4. So that's how I can find out where my asymptotes are on this particular. Question, Jack?
Yeah, I got it.
So, and we're supposed to do it from negative pi over 4 to 3 pi over 4. Unfortunately, if I do my scale to be pi over 8, which I kind of want to do, I would end up being 1 short. So we'll make our scale pi over 4. So pi over 4, pi over 2, 3 pi over 4, pi, and then negative pi over 4, etc. All right. So, actually, let's keep blue here for a second. So my asymptotes, no, that didn't write. Sorry, negative pi over 4. So my asymptotes are at negative pi over 4 and pi over 4. Now, once I have those, everybody feel confident they can find all the rest of the asymptotes? It's just these were 2 units apart, 2 hash marks on a graph apart. So our asymptotes are going to keep going. Did everybody see how I got all those other ones from just those first 2? All right, once we have the scale, it never changes, right? It's periodic, so it repeats itself every pi. Or in this case, actually I'll ask you what the period is in a second, but in this case it's not pi. Yeah?
So you do a negative version of, or you do a negative and a positive of negative, or a pi over 2.
Yes.
So you can get so you can get the negative asymptote.
So I can find out what these first 2 asymptotes are right here.
So you do a negative version of it?
Yeah, generally speaking, we kind of think of, you'll see a reason for it in the future, but generally speaking, we think of, like, if we have to do 1 period of tangent, it's better to do it between 2 asymptotes than it is to do, like, this portion, this portion here and then this portion here. We like to have 1 contiguous thing. So if we only have to do 1 period, this is the easiest period. We'll see in 4.7 why that is, but so we're trying to find those 2. We could alternatively, as you said, set this equal to pi over 2, and then set the other one equal to 3 pi over 2, because that's another asymptote on our original. And that would work as well, it would give me these 2 instead. Yes?
So pi over 2's the
Puberty's a
yeah. So pi over 2 is it's the period.
Yes,
I
pi over 2
need to
ends up
find
being the
that by
period.
2 to find the.
Yes. So our period, if we want to figure out what the period is, the default period for tan is pi. So pi over 2 would be our period. Does that make sense? That's the distance between our asymptotes. From negative pi over 4 to pi over 4, that's pi over 2. So that's why those align. Yes?
So does the period
So like tan period is time.
Yes.
But for these functions, you have to do like an equation to find out the period for that function.
Yeah. So again, if you want to, you could do. You could do the exact same formula that we use for sine and cosine, except what's the default period for like the parent function tan of x? It's pi instead of 2 pi. So instead of 2 pi over b, it's just pi over b. Yes.
How do you find the asymptotes? I'm confused about that.
I take this guy right here and set it equal to negative pi over 2 and pi over 2 and solve. Well, what you can kind of think of is tan of on our original. I'll go through it anyways, but on our original, pi over 2 is an asymptote, right? Negative pi over 2 is an asymptote. So if it doesn't really matter what we're plugging in for x, it really matters what we're plugging in for the argument for tan. So we're trying to figure out what makes what makes it so we're taking tan of pi over 2, right? So I figure out what makes 2x equal to pi over 2. What makes 2x equal to negative pi over 2? So that way, if I plug in negative pi over 4, what do I get? I'd be plugging in tan of negative pi over 2. If I plug in tan of pi over 4, I get tan of positive pi over 2, which are our asymptotes, right? So we're figuring out what would I have to plug in for x for it to blow up. Well, I'd have to plug in negative pi over 4 and pi over 4. Yes?
Do you always, so when you do that, you always set the b to negative pi over 2 and pi over 2?
Yes. And if we have a phase shift in there, it's not just, so if this was like 2x minus pi or something like that, we'd have 2x minus pi equals 2x minus pi equals. So that whole argument.
So aren't there the other points they've defined?
Yes, we're not done. We actually haven't graphed anything yet, right? We just
plug in pi over 8.
have our asymptotes. Yep. So what we're going to do is halfway between all these sets of asymptotes, we're going to have our intercepts. Now halfway between those, we're going to have our best version of key points. Now, notice on our parent function, that's the point pi over 4, comma 1. This is the point negative pi over 4, negative 1, right? And so what ends up happening is all we have to do is, that's where this 3 comes in. So if it had just been tan of 2x, I would have had a point here and a point here. But since it's 3 tan of 2x, where do you think they're going to be?
3.
Yeah. So this point right here and this point right here. And again, they're not perfectly on the grid lines and everything like that, so, go ahead and label, that's negative pi over 8, negative 3, this is pi over 8.
What's the scale of the y thing? Is it just 1?
Yeah.
How'd you get pi over 8?
Yeah.
It's halfway between 0.
So, yeah, halfway between 0 and pi over 4, right? So I chop it in half, and that's how I got my intercepts. I chop it in half again, that's how I figure out where it's equal to this a value here.
And that's always?
Yes. And now I connect it.
So the key points is that pi over 8?
Yeah. And our key points, we only really have 3 key points. It's these 3 points. Then we have our asymptotes, or our other 2. Again, I'm just filling this in. It actually asked us to do negative pi over 4 to 3 pi over 4, so really I just need to be, I would only have needed to graph this guy right here. These look kind of like they're straight lines. They are concave. They are bending. Any questions on that? We're going to do a cotan next. They're very, very similar. The process, the idea behind the process is very similar. The one thing it's kind of hard to see on this part right here, there is an asymptote. at 0. Cotangent. Because it's x over y, so it's 1 over 0 at 0. So that there is an asymptote at 0, and that's our axis right there. All right. Does this look familiar? Looks pretty similar to our tangent function. Well, what happened? Yeah, instead of increasing, we're decreasing, and then we shift it over a little bit, right? So we could take tan of x, make it negative, vertical reflection, and then shift it over by pi over 2, and there we have it. This is all exactly the same directions here. So let's just get straight to it and do cotangent. Now, the only real big difference besides it decreasing again is my first asymptotes are 0 and pi. So what do you think, if I'm trying to figure out where my asymptotes are now, what do you think I do?
That formula, pi over 2x.
Pi over 2x equals what? It's actually going to be 0 on this one because it's cotan. And pi over 2x equals pi because it's cotan.
Where does 0 come from?
So why do you use pi over 2 instead of 2? Oh, because the argument.
So, we're trying to, in tangent, we were trying to find the first asymptotes. Really think of this guy right here and this guy right here as my first asymptotes, right? So I set the argument equal to negative pi over 2 and pi over 2, and I found what would give me those values, and those gave me my new asymptotes. Now, on cotangent, what I've got here instead, my first asymptotes are at 0 and at pi. So I'm going to set my values into equal to those, because those are my original asymptotes for my parent function of cotangent, right? The asymptotes for tan of x are at negative pi over 2 and pi over 2. The asymptotes for cotangent of x are at 0 and pi. So I'm just setting them to whatever the original asymptotes were. And again, there are infinitely many asymptotes, but we're picking 0 and pi. You all right there, Jack?
I'm good.
So, if I solve this, what does x equal on this one? And on the other one?
2.
So what's my period?
2.
2, right? The distance between those is 2. So, let's just go by 1/2. Doesn't give me a thing I have to graph, so we'll still go by 1s. And we have an asymptote at 0, we have an asymptote at 2, so we also are going to have an asymptote at negative 2. Mark?
Well, never mind. What are PW2?
Yes. What we're doing is from 0 to pi, that's one full period, and it's just going to keep on repeating itself like anything else. What do you think my next step is going to be?
Why couldn't you have just put like the asymptote on there exactly? 2 values, you just kind of each one as 1.
What's that?
Scale.
Well, the reason why I did this scale is because now when I cut it in half, I'm going to have that guy right there. And then when I cut it in half again, it's going to be on. Like you could. You don't have to have it by 1/2. You could have it by 1s or whatever.
Oh, is that just to help show like the key points?
Yes, because now my key points are going to be how far up and how far down. 1/2. So and then I can plot them right here and right here on the line, right? I just did it so that way it worked out a little bit nicer. I didn't have to. Oops, except I just did it for tangent. This is cotan, so just the other way around.
Oh, and the A is 1/2.
Why is the first point on 1?
Why is the what?
Why is the first point on 1?
Why is the first? I was missing the last sentence part.
Because it's halfway between 0 and 0.
It's at so Cotan is decreasing, right? So it's above, not below. And then this number right here is 1/2. So instead of being at 1, it's at 1/2. If this number had been 3, it would be up here at 3.
I didn't see the asymptote at 0.
Oh, okay. And again, probably want, especially on a test or quiz, maybe not on your homework, but on a test or quiz, label your points, 1/2, 1/2. This one's very clearly 1, 0, but then this one is 3/2, -1/2. And again, it keeps on going forever, right? It's gonna. We're just looking at one little snapshot here. Yes, Henry.
So you got the x value. It's 1/2 up and 1/2 down from the A.
The y value from the A.
Or the y value.
The fact that this is 1/2 and this is -1/2 is from the A. But 1/2 and 3/2, how I did that again was my asymptotes were at 0 and 2. Cut in half, and I'm going to cross at 1.
Okay.
Cut that in half again, and it's going to be 1/2 and 3/2.
You always split it into equals like that.
Yeah. And you could even use that technique for sine and cosine if you wanted to. It's just, it seems to, for whatever reason, the methods we went over last time make more sense for sine and cosine, and then with tangent, these ones make more sense. Because I think the big problem is with tangent when we modify, since we're working from the center, like both sides close in rather than on sine and cosine, it looks like you're starting someplace and stretching one way. And so that seems to be a little bit easier to digest. So, any questions on this cotangent problem? Everybody understand why we're setting for cotangent we set it equal to 0 and pi, and for tangent we set it equal to -pi/2 and pi/2? Again, this is not the only way to do this. You could just look at this and say the period is pi divided by pi/2 gets my period of 2, and then work it out in your mind. How using logic you can do that. That's fine. That's how I did it for a long time. I actually just find setting it equal to 0 and pi is a little bit easier. Yes.
So, I know if you put like a negative out front, like function, it's gonna put it over the y-axis.
Over the x-axis.
Right. No, if it's inside.
Oh, inside. Yes. Yes.
And then, so if you put like, say a negative on a tan graph, would that be the same as cosine?
Yes. I mean, with a shift as well, still.
Yeah.
But yes, this is, if I flip this up and then shift it over, that is tangent.
Okay.
It would be the same as 1/2 tangent of pi over 2x with a phase shift.
Alright.
Or negative 1/2, sorry, the minus sign. And why does it not matter whether I have a minus sign out in front or inside the argument? Because tangents and cotangent are both odd functions, right? So that's why you get the same result regardless of what you do.
Right, so negative doesn't matter.
It does where it is. Remember, the minus sign come out front for tangent and cotangent. The minus sign itself matters, but where it is doesn't matter. Exactly. All right. Now, this is our last little bit here. These are quite a bit easier. Now, just to be so we're 100% clear, if I ask you to graph something on a quiz or a test, these dotted lines are not going to be there. All right? But if you know how to graph sine and cosine, you know how to graph secant and cosecant. We just have to do one additional step. Yes, James?
So would you just graph the sine of whatever it is with the shifts and stuff? And
Yes. Yes. So all we're going to do here is, remember, so how do sine and cosecant relate to each other? Cosecant is reciprocal, 1 over sine. So when sine of x is equal to 0, what is cosecant of x?
Not.
Doesn't exist, right? 1 over 0, right? 1 over 0, undefined. So it blows up whenever sine of x is equal to 0. So looking at this graph here, it's going to blow up there, 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 Does everyone agree with me on that? That's everywhere the sine function is equal to 0, we're going to have 1 over 0, so it blows up. Now, the actual graph is they're going to touch right at the value there, but it's going to blow up and go the other direction. Because remember, when we're approaching these, like this is 1 over something really small but negative, as we approach those asymptotes, this is 1 over 0, or something really close to 0 but positive. So we can just go ahead and for these, as far as the key points and whatnot, realistically, have your asymptotes. And then, so I could go ahead and say, this is plain old sine of x, so this is, x equals 0. Let me label it in blue here. X equals 0. And then, what's this point right here? What's this asymptote?
X equals 4.
X equals pi, right? How do I know that? How do I know my scale? Because it was told me it was sine of x, so the period has to be 2 pi, right? So the first half is pi, second half is another pi. All right, so I've got that, and then what's my next asymptote? 2 pi. What's this point right here? Pi over 2, comma 1. 3 pi over 2, comma negative 1. And that's kind of the amount of labeling that you would expect. So again, the key points are the asymptotes and the peaks and valleys. It's still 5 in a period. One of the things people a lot of times make a mistake on is if I say graph a full period or something like that, or if I give you a graph and say, what is the period? You look at this and say, oh, from here to here is pi. So my period is pi. But that's incorrect. Because I need to have one of the ones that goes upwards and one of the negative ones. So the period is still 2 pi. Don't just look at one branch of it and say that that's the whole thing. Right? Even though it repeats itself, kind of, it's still in the opposite direction. It's not exactly the same. Yes?
So if you're asking for a full period, you grab 2 of them, or that full?
This right here, yeah. So a full period is that right there. Yes? Yes. All right, so this one. Notice, if I'm trying to graph secant of x plus pi over 4, what am I going to graph first? Cosine, because cosine and secant, they're reciprocals of each other. So the cosine of x plus pi over 4, that's this line right here. All we need to do is peak is normally at 0, 1, shift it to the left pi over 4, so we have our new peak here. We know that that's negative pi over 4. Right? So we graph that, and then we go again. And I'll just do one period here.
So it's always going to be forward?
What's that?
Is it always going to be forward?
What do you mean always 4?
Like 4 spaces in between, or is it?
No, because neither of these has changes their period. But if we change the period, it could definitely change.
The period is 2 pi over b.
Yep, 2 pi over b, and b is 1 in both of these. So this would be negative pi over 4, 1, and this would be 3 pi over 4, negative 1. And then x equals pi over 4, x equals 5 pi over 4. That makes sense? So last one. Again, it goes nice and quickly because it's already graphed, but theoretically we know how to graph that guy right there. Amplitude is 2, period is pi, vertical shift is 3. Right? So theoretically you should be able to graph this pretty quickly now. Cosine starts at a peak. So again, cosine would start there, 2 cosine would start there, 2 cosine plus 3 starts up there. our period is now pi instead. How do I know my period is pi?
2 pi over 2.
Yeah, 2 pi divided by that 2 that I just circled, right? Why is it not just plain old pi divided by that? Because it's not tangent or cotangent, right? Those are the ones where it would be pi. So now, this one, where does this graph cross 0?
No.
Nowhere. But it doesn't really matter. It's not whether the function crosses 0. It's whether we're taking cosine of a place where we end up with 0. So what we can kind of do is look at this and say, we're shifting up 3, so everyone agree that my new midline is at y equals 3? Right? Again, you don't have to draw that, but that's kind of nice as a visual aid. And we knew it had to be y equals 3 because of that 3 right there. So, now I'm going to draw my asymptotes wherever I cross that midline. And again, you don't have to fill out your graph with all of these. I'm going to label everything on one full period. Let's see if I can. So this point right here is the point 0, 5. Can anyone tell me what this point is right here? Yes.
Pi over 2 negative, or no, pi over 2 1.
How did you know it was pi over 2?
Because the key points are pi over 4, and you just multiply it by 2.
Yeah, every key point is pi over 4 because our period is pi divided by 4. So key points again on this are the minimums and maximums and the asymptotes. So minimum, asymptote, maximum, asymptote, minimum, etc. So I get pi over 2 comma 1, and this is going to be x equals pi over 4. This is going to be x equals negative pi over 4. It's going to be x equals 3 pi over 4 for that asymptote. Yes, Sam.
The scale.
What is the scale? Each hash mark is pi over 4. So this is 1. Those go by 1s, and these go by pi over 4s. But you should, even if I didn't give you this, if I didn't give you what the scale was, if I gave you the formula, you should be able to figure out the scale. James.
So as long as we're doing it proportionally in our homework or on tests, we don't have to label the scale.
No, I would like you to. In this case, I labeled everything in here, so we knew the scale for my labels, right? But in general, what I want you to do is kind of go through it, label every key point in one full period, and then have everything to scale. If your things lie on grid lines and you so notice our first asymptote is x with power 4. That lies on a grid line. Well, then I can intuit yes, it's power 4. If your graph is over here and you just labeled this as x is 5 power 4, x equals 7 power 4. We were all the way on the right side here. Then yeah, could I figure it out? Sure, but I would want to know the scale from there. Does that kind of make sense? I don't want to ask too much of redundant information, but yes.
So for all of these, you pretty much graph the sine and cosine of it, and then base it off of that.
Yeah, if I had a question and it said graph y equals 5 cosecant of 3x plus 2. If I had something like that, what I would do is I would graph cosecant as a reciprocal of what? Sine. I would graph this and then do the process that we
It has
did.
the same like transformations. and stuff.
Exactly the same. So if I can graph this, I can then do what we did on those three
You don't
examples.
really need key points. You just kind of base it off the max.
Well, the key points end up, the x values of the key points end up really matter,
Yeah.
right? Because those are our asymptotes, where the midlines, and then they're the minimums and maximums
Yeah. Okay.
from there. So they do matter, although the y values of the midline don't really matter, but that's not that hard to get. So generally speaking, I kind of graph it as accurate as possible, including key points. You don't have to label them until you've got the other graph, but you do need to know all that stuff and graph it accurately. Any other questions?